At some point in the design process, you as the designer have to confront the blank sheet of paper. And that is going to be a challenge for many of you. Now, of course, you'll probably have some ideas for concepts that are responsive to the challenge you've taken on. So go ahead and get those started. But what I want to do now is explain an idea, a basic principle that's called decomposition. And this is a technique, I'm going to explain it conceptually, and then in subsequent videos I'm going to give you some specific examples. The basic idea is that you have this big design problem, and for most people that design problem is unwieldy or hard to get a handle on, and you're stuck in terms of not having any good ideas. So the basic idea behind decomposition is you're going to take that problem and you're going to divide it into pieces or subproblems. And so step one is divide into subproblems. And there are many ways to do that. And in fact, I'm going to tell you about three eventually. You can do it by key or latent needs. That is, you can consider the key or latent needs that are part of the overall design problem. You can decompose by sequence of user actions. Thirdly, you can decompose by function. And I'm not going to explain how to do that just yet, but I just want to point out that your first step is going to be take a big design problem, break it into two or more subproblems using one of these techniques. And in fact, you'll probably use several of these techniques as you try different decompositions of the design problem. Then the second step is going to be solve the subproblem. And the idea is, considering only the subproblem in isolation, what are some possible concepts that would be responsive just to that subproblem? And so you solve subproblem A, you solve subproblem B, and you solve subproblem C, or however many subproblems you have. And then the third step is you integrate solutions. And basically this is like choosing from a sandwich menu. You're going to take one from B, one from A, one from B, one from C, integrate into an overall solution concept. And you can take another one from A, another one from B, another one from C, and you get some additional solution concept. And if you think about it, let's imagine that there are 7 of those, and 7 of those, and 8 of those. Then basically what you've got is you got 7 times 8, or 392 possible combinations. And the whole idea is that for most people, while the big design problem might be unwieldy, for most people, if they can break the problem down into a smaller problem, they can more readily solve that smaller problem. Once you've solved those 2 or 3 or however many subproblems in isolation, then that integration or combination step is more straightforward and will lead you to a bunch of different ideas. I said there were at least 3 ways to do that: by key or latent needs, by sequence of user actions, or by function. Let me illustrate how to do it by key or latent needs. So if we go to our cart example, we had several latent needs. And let me just take 2 as an example. One was that the cart could be used as a tabletop or as a table. And the other was that the cart navigated curbs. So the whole idea here is if you then say, well, let me not solve my cart problem. Let me just see if I can think of different ways to make a table. And so in the abstract, let me just think about what some options for a table might be. Well, one option for a table might be that I have a box and the box has a top on it. All right, so box with top. Another option might be that I have a folding table, like a banquet table. So I have a table with hinges that have legs that fold down. And a third option might be that I have a table, a pedestal table, and I could imagine a pedestal table that might have a lift to it of some kind, so that it could be collapsed. All right. So there are three approaches to creating a table that have nothing to do with a cart. All right. Now, if I look over here at cart navigating curb, we might say, well, what are some ways that a wheeled vehicle might navigate a curb? So here are some curbs. And one way might be, if you think about the way commercial hand trucks work, they often have, so there's a commercial hand truck, they often have a kind of a skid, that a structural element that sometimes has a piece of plastic on it to make it low friction. So it's a skid. And how else might you navigate a curb? Well, you might have a really big wheel. That would be a nice way to do it. Or, I don't know, it might be interesting to think about a smaller wheel, but then one or more very small wheels that give a kind of give the effect of having a very large wheel, because there's a couple of rollers there that allow the curve to be navigated. All right, so again, that's thinking about just the curb problem. And this is the roller solution. All right, so now the trick, step 3 in the decomposition principle, is to take one from column A, one from column B, and form an integrated solution. So just for instance, let's take the idea of a folding table and the idea of the roller scheme and see if we could come up with a cart. So we might imagine, let's see, here's our cart. We have a little wheel. We have some rollers. And we're going to have some kind of horizontal element that would store our stuff. And our cart is going to have a handle on it for pulling. But it's going to have this nice feature, which is going to have a little hinge there, which allows that handle to fold down. Which would allow this thing to be stably configured as a little table. All right, so that's an example of, taking that and taking that and creating an integrated solution. Now, that's a very quick thumbnail sketch for what that concept might be, but I would then go elaborate, think about it a little more carefully, think about how that concept of the wheel, a couple rollers, and a fold-down handle to form a stable table might actually look as an integrated solution. But hopefully you see that by decomposing by these latent needs, by these a couple of focused issues really, I'm able to generate some solutions that solve or address just that need, some solutions that address just this need, and then combine them in order to create some solution concepts.